Here's a question. What can we learn using a supercomputer like the one in our Supercomputing Center? Take Dr. Tornado. She loves tornadoes. She wants to know everything about them. What makes them form? What determines their strength and size? Why do some last long while others don't? Dr. Tornado doesn't have the resources to build a big tornado-making machine. And where would she safely test it if she did? She needs a way to make a tornado without making a mess. So Dr. Tornado gathers all of her friends, scientists and students alike, and they go on a hunt for data. Their goal is to collect information like temperatures, precipitation, wind speeds, barometric pressure, and radar data, and put them all into our supercomputer along with the laws of physics, equations that govern the Earth system. To do this, Dr. Tornado's team follows potential tornado-producing storms to make observations, send out weather balloons, and place tons of stick nets, mini weather recording tripods, all around the area. And Dr. Tornado? She drives a huge truck with a radar on the back as close to a tornado as she can, without getting hurt, of course. Remember, Dr. Tornado is a trained scientist, so don't you go trying this. Once all of the different bits of data are collected, they are entered into our supercomputer and added to a model of the atmosphere. Because there is so much data and the equations are so complex, you need a supercomputer to calculate the outcome. Now here comes the fun part. Dr. Tornado is able to change the settings of the model to see what effects it would have on the outcome. What would happen if it were a few degrees cooler? What if there was less water vapor? What if the storm was moving faster? Each slight change has an enormous impact on the outcome. This way, Dr. Tornado can better understand how a tornado works, and in turn, we can make better warning systems that will save lives. But that's not all. Other scientists who have built models similar to how Dr. Tornado built hers can remotely log in to use this supercomputing power. Models that can predict the path of a hurricane, that can predict solar flares, and that can help us better understand the Earth's climate. In this way, we can answer all sorts of questions. Like, how much water and energy will we have available to us in the future? What will our agriculture look like? How high will the sea rise? How will climate change affect extreme weather events? And how will solar storms affect us here on Earth? These are just a few of the ways we can benefit from the Supercomputing Center. Think about what questions you would want answered.